Hello and welcome back to this class. Let's solve under example under the study of um, reduction of vector in 2D, right? So let's see how we can possibly resolve these vectors in 2D and apply what we know. First, this is a diagram here. Knowing fully well that is still what we know, right? But let's see how we can possibly get this value, please. First, I will draw out my FBD, first priority, FBD, free body diagram, FBD. So it's more like saying I'm having a plus sign, right? So something like this, right? Something like this, such that here to here gives you this. That's 60 IB, right? The angle to the horizontal is 25. All right. Next part here, I have one here going down this way. The force there is 40 IB. Angle to the horizontal is of course 60 degrees. Finally, this one goes this way. That's this one here. This 50 IB. The angle also is what? 50 degree. Now, of course, observe this. 60 and 40 are both inclined to the horizontal, whilst a 50 is inclined to the what? Vertical, as you can see. All right. So let's work on this, please. Let's work on this stuff. First, I want to be applying our concept of equilibrium to get a value, right? So this gives you summation. Let's get the values, please. Summation of horizontal component. Of course, we are asked to find the resultant force, and we need these two: summation of horizontal component and vertical component, right? So summation of f of x, summation of f of x equals 0. If I resolve this one to the okay. You know what? Let me call f1 to be 60. Theta 1 should be 25. Let me call f2. Okay. Let me call f2 to be 40. Theta 2 to be 60 degrees. Finally, let me call f3 to be 50. Theta 3 should also be what? 50. So please, this IB, whatever, just put in it in there. Or just using the value, or not using the IB there. Right? From here, this gives you, resolve this one to the horizontal. If I resolve F1 to the horizontal, that gives you F1 cos theta 1 for this one here. If I come down here, if I resolve this one to the horizontal, that gives you at this quadrant, this is the first quadrant. At first quadrant, S is positive, right? Y is negative. Resolve to the horizontal, that gives you plus F2 cos theta 2. At this point, resolve to horizontal, that gives you minus F3 sine theta 3. Why sine? Because the angle is not horizontal, it's to the vertical. Please, so I have this one here. From here, what do we get from here? So summation of f of x now will be equal to f1. F1 is 60. 60 cos theta 1 is what? 25 plus f2, that's 40 cos theta 2 is 60 minus f3. What's f3? 50. 50 sine theta 3 is of course 50. I have the place. Summation of f of x will be equal to, let's punch calculator and see what we get. $60 cos 25, that gives you 54.378. Have 37, okay. Plus 40 cos 60, 40 cos 60, that gives 20 minus 50 sine 50, 50 sine 50, that gives 38 0.30. Work on this. Summation of f of x now will be equal to, work on this, 54.37 plus 20 plus, minus 38.30. This might give you 36 Newton if you want to, right? 36 Newton. 36 Newton I. All right. 36 Newton I. That's f of x. I need this value. All right. Next task, apply the second condition of equilibrium, which is summation of vertical components. So I'll take this diagram off. Take diagram off and see what we get. So summation of vertical component. That's of course summation of f of y equals 0. For f of y equals 0, I'm actually taking the forces to the vertical, right? Oh man, okay, from here, take f1 to the vertical. That gives you f1 sine, please. That gives you summation f of y is equal to f1 sine theta 1, of course, plus for f2. If I take f to this one here, to the vertical, to this place here, gives you sine. That gives you f2 sine theta 2. If I take this one here to the vertical, to this point here, that gives you cos. That gives you negative f3 cos theta 3. All right. Yeah, all right. If I take this one here to the vertical, the angles on the vertical becomes cos. I have this one here. And to the vertical here is going downwards, negative direction. That I have negative here. Or perhaps at third quadrant, x is negative, y is negative. This I have negative value here. All right. Put in values. Summation f of y equal to, what's f1? 60 sine 25 plus f2 40 sine 60 minus f3 50 cos theta 3. That's 50. All right, from here, what do we get? This one gives you summation f of y is equal to, I will punch individual value and see what we get. Let's see what we get. From here, if I punch 60 sine 25, 60 sine 25, this one gives you 25.35 plus, let's do 40 sine 60. That gives you 34.64 minus 50 cos 50. 50 cos 50 that gives you 32.139. Work on this. This gives you the value of summation f of y will be equal to, work on this, let's see what we get. 25.35 plus 34.64 minus 32.139. That gives 27.85 Newton J. This is my value for summation f of x and summation f of y. I have not started at all. Let's not start question, right? So I won't erase this two value. Okay, perhaps let me come here. So let me just put the value here. Summation f of x gives about 36 Newton, right? Newton I. Newton I, summation f of y. That one gives about 27.85 Newton J. Alright, I've gotten the values of f of x, f of y. Let's now get each of the stuffs here. Let's look for resultant force, resultant magnitude or magnitude of resultant force, resultant angle, resultant direction. Welcome back. Let's get I. For I, we are asked to find resultant force. That's Fr resultant is equal to summation f of xi plus summation f of yj. Alright, getting values. The resultant force of that diagram gives you f of x is this value, that's 36 Newton I, plus f of y gives you 27.85 Newton J. Newton is common, bring it out. That gives you that the resultant force of diagram gives you 36 plus 27.85. This I, 26I plus 27.885J. Then the Newton should be outside this way. This is the value for the resultant force of that diagram. Right, let's proceed by getting the magnitude of the resultant force. Let's get magnitude. That's magnitude of the resultant force, Fr, equal to the square root of summation f of x squared plus summation f of y squared. From here, the magnitude of the resultant force is equal to the square root of summation of x is this value, that 36.36 square plus into f of y 27.85 all square. The magnitude of the resultant force is equal to the square root of 36 square gives what value there? 36 square, that's 1296. 1296 plus 27.85 square, that gives 775.62. Alright, 6225. Alright, from here this gives you F resultant, magnitude of resultant force is equal to the square root of, add this value up, 1296 plus 775.6225. That gives you 2071.6225. Alright, so finally the magnitude of resultant force will be equal to the square root of 2071.6225. That's 45.5 Newton. Alright, I've gotten the force, resultant force, magnitude of resultant. Let's get the angle, right? The angle I. For the angle, we said that's given by theta is equal to tan inverse of summation f of y over summation f of x. Alright, that's how you get your angle. Let's get angle. Take this one off. From here, this gives you theta is equal to tan inverse of something f of x. F of y is this 27.85 over 36. Theta equal to tan inverse of 27.85 divided by 36. That gives 0.7736. Take the tan inverse of the value, zero point 0.7736. That's 37.7 degrees. That is your angle, right? And the angle is positive. It means it will be in the first quadrant. That's a hint. All right. Also, let's get direction. For direction, what do you know? What do we know? So direction is simple as I have this way. Let's say I have this one this way. The angle is positive, so it should be somewhere around there, and it's 30.7. So let's say here to here is what? 37.7 degrees, right? And the force here is called the one resultant force. That's the value. That's 45.5 Newton. This is my direction diagram. This is how you solve this particular question using the idea or the concept of resolution of vectors in 2D. See you guys in our next video. Hi there. Are you a candidate for the upcoming 26 JAM/WAEC examination? If yes, then I want to invite you to my JAM and WAEC tutorial class. In this JAM and WAEC tutorial class, we'll be looking at several topics such as mathematics, chemistry, and physics. For each of these topics, we'll be doing an in-depth teaching as well as solving past questions for the last 10 years for each of the topic. If this interests you, do well to click on the link you see in the video description, or you can message me up through my WhatsApp number as displayed in front of you. See you guys in the next class, and welcome to Excellent Link Academy.
Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both, right? So once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner. I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen,